going into this question, let us quickly recap the basics of projectile motion. So we know that in projectile motion, when an object is projected at an angle theta with velocity v, right? With velocity v, it can be resolved into two components. One being the vertical component, which represents the vertical motion. Two being the horizontal component, which represents the horizontal motion. Now, the horizontal motion is a constant motion, right? The horizontal motion is a constant motion, which means acceleration along the horizontal direction is zero, and the body always has the same magnitude of horizontal motion, right? Why? Because acceleration along the x direction is equal to 0. Whereas acceleration along the y direction would be acceleration due to gravity, which would make the vertical velocity vary in a different pattern. How? When it has two components like this, the vertical component after some time will be less in magnitude, after some time would be even more less, and at one point the vertical magnitude doesn't exist. While the object is coming down, right? While the object is coming down, what happens is the vertical component of velocity will get reversed, but will slowly increase in magnitude, will get reversed, but will slowly increase in magnitude, will get reversed, but will slowly increase and attain the maximum magnitude again. Okay, so this is what happens in projectile motion. Now, at the highest point of flight, the vertical component of the velocity becomes zero because gravity opposes vertical motion. However, the horizontal component of the velocity remains constant throughout the motion, which is represented by this. So we can say that at the highest component, the highest point, the only velocity is Vx. And what becomes zero? Vy becomes zero. Alright? Now coming to the question. A ball is projected with kinetic energy E at an angle theta is equal to 60 degrees. So here the theta is 60 degree. The kinetic energy of this ball at the highest point of its flight would be. So at the highest point of the flight, the vertical component of the velocity becomes 0, which means Vy is equal to 0, and therefore the only component of V, if I have to say this point as A, which is the highest point, then velocity at A would be only due to the horizontal component, which is Vx. And what is Vx? Vx is V cos theta. What is theta? Theta is 60 degrees. So this becomes V cos 60, which is V into 1 by 2. Therefore, we can say that at A, velocity at A is equal to initial velocity V by 2. Therefore, what would be kinetic energy at A? It will be half m into VA square. What is VA? V by 2 the whole square. So here I'll write this as half m into V square into 1 by 2 the whole square into 1 by 2 the whole square. What is 1 by 2 the whole square? It is 1 by 4. Now, what is half mv square? See, half mv square, the object is projected with the velocity v here. So it is actually the initial kinetic energy E. Therefore, I can say that half mv square can be replaced by kinetic energy, initial kinetic energy, which is ke0, or which is equal to E into 1 by 4. Therefore, ke at A, my bad, this is not ke at 4, this should have been ke at A. Ke at A will be equal to E by 4, which gives us the correct option as option C.